Alright, so we're going to do a real quick review on solving right triangles. So there's really two things you can do. You can use SOHCAHTOA, I'll write it up here, to solve for missing sides or angles, or you can also use the Pythagorean theorem. So if you have two of the three sides, I would go straight to the Pythagorean. If you've got an angle and a side, I would use SOHCAHTOA, or if you're missing an angle and you have two sides, once again I would go SOHCAHTOA. So if we look here, first triangle that we've got, we're looking for x. If you look at it first glance, the 34 kind of throws you off because you kind of want to jump straight to SOHCAHTOA. But then if you realize that you have two of the three sides, we could easily do 12 squared equals 4 squared plus x squared. You can do the Pythagorean. So then we would just type in 12 squared minus 4 squared, take the square root of that. That tells me x is 11.31. If you look over here, we're trying to find an angle. So then you have to remember that missing angles, if we're looking for an angle, means we have to take the inverse. We've done that before, just a little reminder. Missing angle means take the inverse. So we're looking for angle x. That means we have the adjacent leg and the hypotenuse. Remember, adjacent runs into the angle. Hypotenuse is across from the right angle. So then with the adjacent and hypotenuse, we're going to use cosine of my angle, which is x. We don't know what that is, and that's equal to adjacent over hypotenuse. So then we'll type in the inverse cosine of 8 over 15. That's going to give me x. When I do that, I end up getting x to be 57.77 degrees. Now these are going to be in degrees, not radians, so that means you want your calculator to be in degree mode. So if it's in radian mode, switch it out because we are going to want degrees out. And then over here, we've got a very similar triangle to what we have up here, but this time instead of two of the three sides, we just have one. So we're looking for this leg. So then you have to figure out, let's see here, what we have, adjacent, hypotenuse. So once again, we'll do cosine. So it's cosine of your angle. So this time 34 gets plugged in there, is equal to adjacent over hypotenuse. Trying to solve for x means we multiply by 10. So then type in 10 cosine of 34. Tells me that x equals 8.29. Now if we go back, I'm going to just draw one over here. This is a separate triangle. Let's say we've got 25 degrees, we've got 8, and we are looking for x. So we know we have opposite hypotenuse, so we're going to use sine. So sine of my angle is opposite over hypotenuse. This time it's a little different in that the x is in my denominator. So we're trying to solve for x, so we'll get it out. Well, that doesn't really help us get it by itself, but we will divide both sides by sine of 24. So x this time is 8 divided by sine, I said 24, of 25. So then 8 divided by sine of 25, I'm typing it in, tells me that x is 18.93.